Alright, so let's start. I hope you guys can see the board clearly. Yeah?
Yes.
Oh, okay, good. So now before I start with what we want to cover today, which will be the last part of Unit 12, maybe or may not be the last part, I mean depending on whether we are able to finish everything today or it goes till tomorrow. But before we do that, so is everybody clear about what we learned in the last class? How the parabola moves depending on horizontally or vertically, depending on the constant that we add with fx versus fx minus 1 or fx plus something. Are you guys very clear about it?
Yes.
Can you guys play with that? If I say, let's do this. If my function of parabola is like this, x squared plus 4x. If I say function of minus x, what will happen? Let's say if this is my parabola. If I am saying function of minus x, what happens? I got one answer from Praneeth. How about you guys? What happens in case of function of minus x? Anybody? And request you guys to keep your video on, okay? So that I'm talking to real you, not virtual you, okay? Function of x to function of minus x, what happens? Do you guys remember? It creates a mirror image against the y-axis, okay? If I say function of x plus 2, what happens? Okay? Or this. Okay. Yeah. So let's do a quick recap because this is what will come out handy for us when we go to the next topic, right? So here's the thing. Just to recall, to help you guys recall, if function of x is x squared plus 4x or y equals to x squared plus 4x, my parabola is like this, let's say. If I am saying function of minus x, it creates a mirror image against the y-axis. So if I say minus x, it creates a parabola here. Okay, equal distance from this one, like a mirror. Now, if I say function of x plus 2, what happens? It shifts my parabola by 2 points upward. If I say function of x minus 2, it moves my parabola by 2 points down. Yeah. If I say function of x plus 2, what happens? It moves to the left. Plus 2 moves it to the left, to the right. And if I say function of x minus 2, it moves it by 2 points to the right. Yeah? No. No. So you guys have to help me recall. I want to know what all we learned in the last class. Did you guys revise by watching the video? Did you guys take a note? I want you guys to tell me, okay? So one answer I have got right, that is f function of x becomes function of minus x. It creates a mirror image against the y-axis. This one is fine. If function of x becomes function of x plus 2, it moves up. If I say function of x minus 2, it moves down by 2 points. Up to this point is fine. Now I want to know what happens when I say function of x plus 2. Yeah, Vaibhav, say louder.
I think if the parabola goes then
Parabola goes down.
left.
Goes to the left. Yeah. Yeah. X plus 2 moves it by 2 points this side. To the right. X minus 2 moves it by 2 points to the left. So minus x flips, plus 2 minus flips, plus 2 outside this thing, shifts it by upward or downward, and then fx minus 2 or plus 2 shifts it to the I want you to come and explain that here. See, these are the playful thing that we have to do, and I want let's see what Pradeep has to say.
I thought x minus 2 will move it this
Minus 2 moves it to this side, plus 2 moves it to the right side.
oh.
Because, see, here you are subtracting. Let's take one example, okay? So let's say this is the example, okay? So here, let's look at this. So always you have to look at this parabola like this, okay? Let's say x squared plus 4x, or let's say x squared plus 4, just for the sake of simplicity. When x is 0, what is the value of y? When x is 0, y is 4. So it touches y-axis, that is fine. Okay? Now, what is the x and y coordinate, x coordinate of this one? We were saying that, okay, x coordinate of the lowest point is, let's say, b by 2a. Negative b by 2a. Okay? So, what is the value? If x is 0, y is, okay, so we don't have to do this part. So here, x coordinate of, here, x coordinate is equal to minus b is what? 0 by 2a. 2a is 2 into 1. So x is 0. Fine. So x equals 0. Now, when you replace, when x is 1, let's take a case which is fine. So see what it is coming down to is, you guys have not watched the video to revise it. That's where we are missing that. Okay? So let's say x squared plus 2x plus 7. This is my equation. Here the vortex is equals minus b by 2a. So minus b is 2 by 2a, 1. So x equals 1. So it is somewhere here. X equals 1, let's say. Now, when I say fx minus 2, what will happen? Meaning, instead of x, I am putting x minus 2. So it becomes x squared plus 2 into x minus 2 plus 7. What is this? X squared minus 4x plus 4 plus 2x minus 4 plus 7. So this becomes x squared minus 2x plus 0 plus 7. So now, here, what is my x coordinate? What is my x coordinate? X coordinate is, again, minus b. So it becomes plus 2 divided by 2a. So it becomes, x becomes 1. So here, x was negative 1, now it is, so it came to this side. Yeah. Okay. So let's do one thing. Let me give you guys an assignment. Let's not repeat what we have learned in the previous class. I want you guys to watch the video of the previous class because we have done this same exercise. I would not want to kind of waste your time to do the same thing again, okay? I want each one of you to go to the video of the previous class, take a note and build that conceptual view of if I am doing fx, if fx becomes f minus x, what happens? If f function of x becomes function of x plus 2, what happens? If function of x becomes function of x minus 2, what happens? If function of x becomes function x plus 2, what happens? Or minus 2. There are three scenarios. When you are making positive, this as negative, what happens? When you are adding something outside the bracket, what happens? When you are adding or subtracting inside the bracket, what happens? These 6 scenarios I would want you guys to kind of note down after going through the video, and one of you will have to explain that in the next class, okay? Next class, not tomorrow's class, I'm saying maybe the class the following weekend, okay? And that should not take more than 5 minutes. You'll just note it down and then you will just explain it, okay? Is that fine? Because this is more of a playful exercise, okay? You should get into your mind that, okay, when I'm adding something, what happens? When I'm subtracting something, what happens? When I'm changing positive to negative, what happens? When I'm adding or subtracting something outside, what happens? There are only 3 movements that happens, okay? One is the mirror image against the y-axis, one is the mirror image against the x-axis, and one is the third is the movement upward or downward, okay? So you have to just map it to that scenario. So just go to the video once, note it down and explain it in the next class. Let's not redo that, otherwise we'll not be learning something new today. Is that okay? Yeah? You guys are very feeble. Can you guys be a little louder?
Yes, sir.
Okay.
Yes, sir.
Alright. So that's the assignment, okay? I did not give you guys assignment. I was thinking that we'll finish up this chapter and then we'll do homework. But this is an extra assignment that is for us to kind of build that mind map with the different scenarios. So what is that we are going to learn today? I gave you guys the topic for today. So let's go through that. Quadratic and exponential word problems. Yeah, that was the first thing. Then exponential graphs, and third one was polynomial and non-linear graphs. So let's start with quadratic and exponential word problems. So Isha, your 6 questions are still, no, out of 6 we have solved 2, 4 are still unsolved. But these are related to what we are learning, so that's why I'm not trying to solve the problem. I'm just going through the basics one more time. Okay? Yeah?
Yes.
Okay. So let's start with quadratic and exponential word problems. So what this means? Quadratic and exponential word problems, meaning whatever we have done with quadratic equation or functions or expressions, that is what we will use in the word problem. A simple example. Let's say somebody says, if you throw a stone from here, throw it upward, okay? After 3 seconds, it comes and hits the ground. Okay? So you are somewhere here. Let's say this is your height. Let's look at this. So you have thrown this stone, it goes up and comes down and comes and hits the ground here. Okay? So this can be represented as an equation like this. Y equals 10t square plus 6t minus 7. Let's give it a, let's say 24. Saying that the movement, so the time, what will be the height of the stone above the ground against time is represented by, let's say, this equation. Tell me after how many seconds this will come and hit the ground again. So let's say you are throwing the stone from here, and this is the equation which this will follow to hit the ground. Tell me after how many seconds the stone will come and hit the ground. So here in this kind of equation, right, you have to think, why is the height? The equation will give you, tell you that, okay, why is the height of the stone after t seconds? This is depending that relationship. Y and t. Y is the height of the stone above the ground, and t is the number of seconds that you have spent. So let's say after 1 second, what is the height of the stone? After 1 second, let's say, what will be the, where will the stone be? At what height? So I'll put 1, t as 1, y equals to 10 into 1 square plus 6 into 1 minus 24. Okay? So this tells me that after 1 second, the height of the stone will be 10 into 1 square is 10 plus 6 into 1, 6 minus 24. So it will be minus 6, 10 plus 6, 16 minus 24, so minus 8. Maybe there was something wrong with the question. Okay? What it says is it will be minus 8, meaning it will be under the ground after 1 second. That is technically not possible, so maybe this question was not 100% correct. Maybe if it was, let's say, 12, then this would have been 10 plus 6 plus 1, so 4 feet. So after 1 second, the height of the stone will be 1 feet, if this was my equation. Okay? So it says, after how many seconds it will be hitting the ground, meaning when will this hit the ground? When y equals 0. When the height becomes 0 again. Yeah? So then what will you do? If you will put y equals to 0, 10 into t square plus 6t minus 12. And this becomes your quadratic equation that you have to solve for t. This will give you two values of t, which says after how many seconds it can potentially hit the ground. So again, this is just an example of this thing, which we are trying to represent in the word problem, which says that, okay, when you throw a stone above, this is the relationship, which depicts that what will the height of the stone against time. This is the relationship. So based on this, if it says, okay, after how many seconds the height will be 10. So you will put 10, instead of 0 you will put 10 and solve it for t, and then you will get the value that, okay, after whatever comes as the value of t, let's say it's a quadratic equation, will give me two solutions. Maybe t equals to 1 and t equals to 5, let's say. So that means after 1 second and after 5 seconds, this will be at a height of 10 feet. Okay? So quadratic equation word problems are no different from what we have learned. Okay? We have learned that, okay, quadratic equation is an equation where your exponent value is 2 for one of the variable, and then we know how to solve the quadratic equation for the variable, right? Using a plus b whole square minus b whole square, converting to that form, or doing factorization, or by using the formula that we learned with discriminants, that the value of, if my equation is x square plus bx plus c equals 0, then my value of x is minus b plus minus discriminant b square minus 4ac divided by 2 into a. So this helps me solve it for x. Here in case of x, it will be t. So you will replace that. So basically, you have to look at the word problem, find out what is the equation, and then how you use your basic knowledge and concept of solving the quadratic equation. Is it making sense so far?
Yes, sir.
Okay, okay. And kids, turn on your video please. I mean, I hope that is okay. Because if I'm not seeing you, I'm not believing myself. Okay? Because your, as I keep saying, your expression tells me 100 things. If I see your faces being confused, that means that I have to teach something again. Okay, so that is on the quadratic equation. Any problem related to this that you guys have in your mind that you want me to solve, let me know. Or let's look at the questions that Isha had given, and is there anything related to this quadratic equation? Okay, exponential graph, also exponential graph. Okay. Alright, so mod. Okay, so this is related to graph. Alright, so once we come to the graph, then we'll look at it. So in summary, exponential and quadratic and exponential word problems. So again, when we talk about, this is quadratic related to quadratic word problem, right? Let's look at what is meant by exponential word problem. Now when we talk about exponential equation, what do we mean? When we say exponential equation, that you should look at quadratic equation. Quadratic equation is only in the form of this: ax squared plus bx plus c, or y equals to ax squared plus bx plus c. Now, this is quadratic equation. When you talk about exponential equation, you are looking at two variables represented in the form of something like this, where one of the variable is the exponent of another constant. Yeah? So this is the only difference. Now when it comes to solving it, let's look at this. Let's try solving. Let's look at some examples. If I have to plot an exponential equation like this, what will happen? This is my coordinate plane. Let's say when I have to plot this, what will I do? When I'll say when x equals to 0, what is my value of y? So when x equals to 0, y equals 3 to the power 0 is 1 plus 1, y equals 2. So my first point is, let's say 1, 2, 3, 4, 5, 6. When x equals to 0, y equals to 2. This is my first point. And this is also called the root or the minimum value of the exponential equation. Okay? Now when x equals to 1, what is my value of y? Y will be 3 to the power 1, that is 3 plus 1. So y will be equal to 4. So when x is equals to 1, y equals to 4, x equals to 1, y equals to 4, let's say it's here. Okay. Now let's say x equals to 2, what happens? When x equals to 2, y will be equal to 3 to the power 2, that is 9 plus 1, 10. 9 plus 1, 10. So when x equals to 2, this is the kind of graph we are talking about. Okay. So basically here if you see again, this is nothing different from a quadratic function equation, just that quadratic function equation gives you a lot of formula for solving it. This one is just based on the values, how you deal with them. Now when you look at this, now some of the behavior that you can observe here is, let's say when this value is greater than 1. So 3 is greater than 1. What happens? For every change of x, every increase of x, y is increasing by a big number. So this is called a positive slope. Imagine if you had equation like this, y equals to 0.25 to the power x, let's say only this much. What will happen? When x equals 0, y is equal to 0.25. When x equals to 0, y equals to 2.25 here. When x equals to 1, x equals to 1, y equals 0.25. So x equals to 1. No, sorry. So when x equals to 0, that y equals to 1. So this is, let's say, 0.25, 0.51. So when x equals to 0, x equals to 0, y equals to 1. This is my first point. When x equals to 1, y is 0.25. When x equals to 2, it will become what? 0.25 square. So it will be 0.25 into 25, 25, 25, 25. It will become 0.0625. Meaning, see, what is happening between this guy and this guy? Here, your base against which the exponent is, that is greater than 1. Okay? With every increase of x, y is increasing. Here, what's happening? Your exponent, the base is less than 1. With every increase of x, the value of y is actually decreasing. So, look at this versus this. Here your base against which your exponent is, that is greater than 1, that's why this is going up. Or this is called positive slope. When value of the base is less than 1, for every increase of x, the value of y is decreasing. This is called negative slope. So this is one behavior that we are observing. That is what you will see in the Khan Academy also when you see the classes video. This is how they describe it. There is no formula given for solving it. I mean, there is no need to solve it that way. It says, it just gives you a view of how you relate or infer based on looking at the equation. So as soon as somebody says function of x or y is equals to 2 to the power x plus 7 versus somebody says y equals 0.5 to the power x plus 7. The difference between these two is, here the base is greater than 1, so it will be an increasing slope. Here the base is less than 1, it will be a decreasing slope. That will be the inference that you will draw from the exponential equations or equation. Yeah. In equation with the exponential equation so far. So this is just to relate. What is my quadratic equation? What is exponential equation? And what is the difference between them? And how do you infer based on how they describe? Yeah? I see a moment of silence and that bothers. Are you guys clear with what I'm saying? Not clear?
Exponential.
Sorry, beta?
It's clear.
Clear? Isha, Athar, Rutvik, everybody clear? Okay.
Yes, sir.
Okay. Rutvik, are we clear? Okay. Okay, got it. So we have just got an assignment for ourselves so far that whatever we learned in the previous class, you guys have to go to the video, note it down and tell me the 6 scenarios. You can also, you can write in a piece of paper and take a picture and send it to me. That's also fine. Say, okay, when function of x versus function of minus x, what happens to the parabola? Function of x and function of x plus 2 inside the bracket, what happens? Function of x versus function of x minus 2 inside the bracket, what happens? Function of x outside the bracket plus 2, what happens? Function of x minus 2, what happens? Here are 6 scenarios I want you guys to put in a piece of paper after watching the video and send it to me. Okay? I want that to be, I would not say memorized, but it should be, what do you call it? We never took any calculation if you have to say 5 plus 2, right? That is known. People might say, oh, you are asking me to memorize 5 plus 2 is 7. But 5 plus 2 we have done so many times that we are used to it. So that's how I want you guys to build that interpretation and put it in a piece of paper. And for kids who have their exams coming up much sooner, it will become a quick reference guide actually. Okay? So Isha, that will be more for you. But everybody else, just make sure that you note it down, because we don't come across this kind of question very often, but it's very important for us to be very clear about what happens optically when you change those things, so that you'll be able to solve these questions in seconds rather than doing the mathematical way. Okay? So that's an assignment. Second thing we did was we just talked about the difference between quadratic equation and exponential equation, and we also saw what do we mean by the different behavior of exponential equation, when the slope is positive, when the slope is negative. Yeah, so it all is a function of the base, and how big or small the base is, that determines whether it's a positive slope or a negative slope. And again, when you say positive slope, what is the interpretation of that? Positive slope simply means how is the value of y changing with the change of x. If my x is increasing and y is also increasing, that's a positive slope. Both are going hand in hand. They are both complementing each other. So x increases, y increases, x decreases, y decreases. That's a positive slope. If the relationship between them is inverse, meaning x increase of x results in decrease of y, that is what is called a negative slope. Yeah? And that is a function of your base against which your exponent is. So far clear? I'll keep on confirming you guys or certifying that it is clear or not clear. So keep responding to my questions, so that way I get the confidence that yes, whatever we have talked so far, that is clear. So we looked at quadratic and exponential word problems. I mean, we just looked at one of them. We talked about exponential graphs. And the next thing that we have to cover is polynomial and non-linear graphs. So before we go to the third one, let's look at the exponential graph for maybe 5 more minutes. So let's say I have an exponential graph which is represented by this equation 1.5 to the power x plus 3. And I have another exponential graph which says y equals to x to the power, 2 to the power 1 by x. I have not taught you guys what is 1 by x here, but I'm still wanting you guys to think about it and tell me which one is a positive and which one is a negative graph, a negative slope basically, not which one has positive slope, which one has negative slope. And it's very easy to do. I want you guys to think and tell me. I mean, not think, basically, use a piece of pen and paper, try plotting it for different values of x, and you will know which one has positive slope, which one has negative slope, or which one has increasing slope or which one has decreasing slope, whatever you call it.
Sir?
Yeah?
Decreasing?
What is that, third?
Decreasing?
Yeah, which one is decreasing, which one is increasing?
Second one is decreasing. First one.
Second one is decreasing. First one is increasing. Can you tell me why? I want to read your mind.
Because 0.5, when you multiply it, it goes lower. Yeah.
Let's talk about first one. So this is increasing, right?
Yeah.
Why?
Because it goes like upwards.
It goes upwards because this is greater
I
than
don't know
1.
how to.
Yeah, this is greater than 1. So simple thing, okay. Now look at this. 1, 2, 0.5, 0.25. Okay. Now, when you multiply 0.25 with 0.25, meaning the power becomes 1 to 2, what the value would be? It will be 0.0625. When you multiply this with this, 0.5 with 0.5, it becomes 125. So this is for x equals to 1, this is x equals to 2. Okay? Here x equals to 1 when your power is 2. Here in this case what's happening? When x equals to 1, this is 1. When x equals to 2, it remains 1 only. When here x equals to 1, this remains 1. Okay, this is 3, right? So yeah. I'm just talking about this piece, okay? Because this is constant. So I'm just talking about this piece here. So when x equals to 1, this is 0.5. When x equals to 2, it's 0.25. Here in this case, 1, be it x equals to 1 or x equals to 2, both is 1. Here in this case, when x equals to 1, it's 2, x equals to 2 becomes 4. So what's happening here? When value of x is increasing, meaning the power of x is increasing, this value is actually decreasing. This value is again decreasing. And when it becomes 1, so 1 is a borderline case for the base. This size is decreasing. Every increase of x is decreasing the value. In case of x, it remains constant. And as soon as you go beyond 1, this value starts increasing. So, the way you will explain this is, if my base on which I have the exponent, it is less than 1, with every increase of x, this value is decreasing. Right? Half of half is 0.25. 1/4 of 1/4 is 0.0625. Yeah? But here, when the base is 1 or more, when base is 1, it doesn't change, it remains the same. But as soon as, if you have 1.1, what will it become? 1.21. For x equals to 1, it will be 1.1, x equals to 2, it will be 1.21. So this value is increasing actually. As soon as it goes beyond 1, every increase of x makes it increase. So that's why this is increasing. Since this is more than 1, this is on this side of the wall, beyond 1. So that's why it's increasing slope, meaning every increase of x, if my x is on this axis, y is on this axis, every increase of x is making the y increase. This is how my graph is going. If you have your base as something lesser than 1, and if you keep on multiplying it, then the value becomes smaller and smaller and smaller. So that is how every increase of x, my value of y decreases. So this is y phase. Your x is increasing, value of x is increasing, value of y is decreasing. So that is the difference. Everybody with me? So
Yes, sir.
this one was clear. Now if you look at this one. This one was a trick question for you guys because I did not tell you what it is. Now, you don't have to worry about it. This is how it will come in the exam also. Not everything will be taught, right? We have to apply our thoughts and then do it. Good thing is you don't have to deal with complex equations. You will have equations, you have to substitute values, smaller, easier values, which helps you do simple calculations and then find it out. So what was the response from you guys? This is decreasing? Everybody says this is decreasing? Is everybody saying that this is a decreasing one? A negative slope? Okay, let's Nobody is saying anything. I'm assuming that everybody said decreasing. I saw Praneeth saying it's decreasing by nodding his head. So let's look at it. Now let's look at this. When x equals 0, this is a problem. I will not worry about it. This is more of a rational exponent. It's a unique case. I will not look at x equals to 0. Let's look at x equals to 1, and let's look at x equals to 2, and let's look at x equals to 3. What happens? We are talking about 2 to the power x equals to 1 gives 1. So when x equals to 1, y equals to power 1. When x equals to 2, my value of y becomes 2 to the power 1 by 2, meaning square root of y. Square root of 2. When x equals to 3, my value of y becomes 2 to the power 1 by 3. 1 by 3 is nothing but cube root of 2. So, more the root, lesser the value. Yeah? So, every value of x increasing is reducing the value because the root value is increasing, so the value is decreasing. That's the reason. Okay? So, you have to always, whenever you are dealing with exponent problems or quadratic equation problems in SAT exam, mostly it will be objective type. Mostly, not mostly. It's always objective type, right? As far as I know. So you have to substitute easier values, smaller values, and find out the corresponding answer, and then based on that you interpret whether it's a decreasing one, increasing one, or whatever is the case. Yeah. Okay. Now there is one more thing that so far everybody is clear or not clear? Clear?
It's clear, sir.
Clear? Ritvik, clear for you as well?
Yes, sir.
Okay. Now, there is one more thing that we want to learn about the exponential graphs. And that is called asymptote. What is asymptote? For any exponential graph, do you guys know what is asymptote? Have you heard about it? Okay. So let's look at this graph. Let's say my exponential equation is 3 to the power x. So far okay? So this is my x-axis, this is my y-axis. Y equals to 3 to the power x. Just by looking at this exponential equation, we know that it has a positive slope because this is greater than 1. So every increase of 1 makes it increase, makes the value of y increase. So it will be something like this. Okay, let's look at it. When x equals to 0, what happens? X equals to 0, meaning 3 to the power 0 will be, anything to the power 0 will be 1. Yeah? So when x equals to 0, y equals to 1. Okay? So this is somewhere here. 1, 2, 3, 4, 5, 6, 7, 8, 9. So when x equals to 0, y equals to 1. This is my 1 point. Okay? Now, what happens if I say, when x equals to 1, when x equals to 1, what is my value of y? It is 3. So my 1, 2, 3, 4, 5. When x equals to 2, x equals to 1, y is 3. This is my second point. When x equals to 2, y is 9. This is this point. When x equals to 3, y is 3 to the power 3, 37. So it will be 0. This is going this way. Now, when we say asymptote, we are talking about look, imagine when x to the power, if we say when the value of x equals to 10, it will be 3 to the power 10. 3 to the power 10 will be much bigger number. Yeah? 3 to the power 10. X equals to 10 here. Let's say this is 10. So this is a very steep curve. And very soon, when x equals to 20 or 30, you will see that it almost becomes like a perpendicular thing. Meaning very small increase of x is leading to a big increase in y. Yeah? Now, look at when x equals to minus 2. That means when x equals to minus 2, it will be what? 3 to the power minus 2? Sorry. Minus 2. That will be 1 by 9. That will be 0.11. So when x becomes minus 1, it becomes 1 by 3 here. Somewhere here. Then x, sorry, not here. When x is equal, it becomes minus 3. What am I saying? When x is minus 1, it becomes minus 1 by 3, point 3 here. When x is 2, when x is minus 2, then it becomes 1 by 9 here. And you will see that this starts coming this way. So there is a virtual line which, see, it will not, in any case, it will not come to hit this x-axis. It remains something parallel to this. This line where it becomes so very close to x equals to 0 but not 0. Imagine when I say x equals to minus 20. Minus 20. What is the value of y? 3 to the power minus 20. Which will be equal to 3 to the power 1 by 3 to the power 20. 3 to the power 20 probably would be maybe 1 billion, 1 trillion. Yeah? So 1 by 1 trillion, let's say. It will be a number like 0.0000, maybe 15, 16 zeros and then 1 to 1 or 4, let's say. So what I'm trying to say is, after a certain point, this just keeps going down, it doesn't become 0, but becomes very much parallel to this x-axis. So this is the line which says that, okay, this is my virtual line, which denotes that after which it becomes a flat line. Now look at 3 power 20 minus, when x equals to minus 20 versus x equals to minus 40. This will be hovering around this line. It just adds few more zeros and by few decimal, few extra decimals actually, decimal points, but doesn't come to 0. So this line is called the x asymptote. Similarly, when you make x equal to, let's say, 60, you will see that for x equal to 60, it starts becoming like this. That every small increase makes it go further up. So this becomes your vertical asymptote or y asymptote. This is just for information. I mean, you'll not have to deal with it. It just helps you derive the fact that when you look at an exponential graph, there are a certain point after which it becomes like what kind of straight. So if you are looking at the graph, if your graph is like this, so there will be a virtual line which will denote the horizontal asymptote, and there will be a line which will denote the vertical asymptote. And this will just help you when you look at how the graph flips against this. So this flips against this asymptote. This is more like, the base which defines the boundary, and against which you can flip it. We can talk about once you guys go through the previous classes video and be 100% sure about how the parabola moves with a different thing, and then we'll try relating this one with that thing as well. Okay. So vertical and horizontal asymptotes are nothing but the virtual lines which kind of defines the boundary for your exponential equation or exponential graph. Say okay, fine. This is the one which is kind of giving you a direction to your exponential graph. Am I making sense so far? Not making sense? Confusing you guys more? What is the deal? Okay so far? I'm sorry?
It makes sense.
Makes sense? Everybody clear? So let's do a recap of what we have learned so far. We looked at the word problem for quadratic equations. We talked about the exponential graphs. We talked about the slope or the positive or negative slope for exponential graphs. Hey Kavyan. No, Goshika, you have joined a little early. I mean, just 2 more minutes. We are just wrapping up the class for the senior kids, and then we will come back to you guys. Okay? So you can stay, listen to the discussion, or you can join after a few minutes. But just wrapping up this class. Okay? You can just stay there, muted. So we looked at the word problem for quadratic equation. We talked about the exponential graph. We looked at the slope and the interpretation of the graph based on the base. When it's greater than 1, what happens? When it's lesser than 1, what happens? How do you interpret that? Then we looked at what is the meaning of the horizontal and vertical asymptotes. And then we talked about the assignment that we have to do outside the class. And you guys will in the next class, I would want one of you to teach me what happens for those 6 scenarios that we talked about, which we had talked before. More like a game, like a flashcard that you guys want to prepare for yourself, right? So, and then we talked about, okay. So then comes polynomial and non-linear graph. So this is what we will do tomorrow. The way we are going to do is, I repeat. Okay. So let's spend 15-20 minutes tomorrow to talk about the polynomial and the exponential graphs or non-linear graphs, and then we'll do the 6 sums that we have. Okay. And by the time we finish this, I'm sure you guys will be able to do the 6 questions that we have talked about. 2 of them we had solved, 4 we have remaining, so that will come through. So Aditi, I'm just finishing off other class, okay? Just stay there for 2 more minutes and then we'll resume with your class, okay? So then we'll solve the 4 sums tomorrow. So tomorrow's class, nonlinear and polynomial graphs, and then the sums that we have talked about. That's what we are trying to do. Any questions?
No, sir.
Okay. And since I had put those questions in the WhatsApp group itself, if you guys get excited to take a look at those questions before the class, that'll be awesome. Just look at those questions and see, based on whatever we have talked about so far, whatever we have learned, is that helping us solve even one of them which we have not solved before. Okay? If not, anyways, we'll struggle with them tomorrow. And in case we are not able to solve all of them in the stipulated time in the class tomorrow, I will solve those and send it to you guys by in a piece of paper or any which way. Okay. So that will be the plan. Yeah. All right. So thank you, Atharv, Isha, Shivatsav, Vaibhav, and Ritwik. You guys are good to drop off, and see you guys tomorrow same time. I'm sorry for the delay today due to some technical thing. Yeah, bye-bye.
After.
Bye-bye.